Hello everyone, welcome to the past paper discussion. So in this video, we're going to discuss question number 13 in this particular series. A very interesting question. Let's get started. Okay, so here Jen is investigating a relationship between two sets of data labeled P and Q that she had collected, and she created a scatter plot with P on x-axis and log 10 Q on y-axis. A point to be noted here. Then Jen noticed that the points had a strong linear correlation. So she drew a line of best fit. That is what we can see here. The purple line, right? And okay, and the line passes to the point 0 minus 1.36, 14.9. First question is, find the equation for Q in terms of P, right? So we know already in coordinate geometry you might have studied this equation of straight line in different forms. So this when 2 points are given, 2-point form is this one, y minus y1 equal m into x minus x1. Okay, how to find m? M formula is this. This is also available in formula booklet. Y2 minus y1 by x2 minus x1. Okay, let me take 0 comma minus 1.3, like this is x1 y1, and 6 comma 14.9 as x2 y2. Got it? Just a substitution and few of work. Y2 minus y1, so my y2 is 14.9 minus of y1 is negative minus 1.3, x2 minus x1, which is 6 minus 0. So 14.9 plus 1.3 by 6. 15, and it's around 16.2 by 6. Yeah. Okay. So let it be. And we can just simplify it if we want. Or it be as 16.2 divided by 6 if I do. It's around 2.7. The simplified version. Now, y minus y1 is equal to m into x minus x1. What is my y? This is the general form, but here x-axis is denoted as p and y-axis means log 10q, right? So let's write in place of y, write log 10q, right? So the formula we need to just refine in this way. Minus what is your y1? My y1 is negative 1.3. So it will go like this. LHS is over. That's simple. Equal x m into my m is 2.7. Just now we have worked it out. 2.7 x minus x1. What is my x1? It's 0. Oh, I did a mistake. Actually, x is the general form, but here we are dealing with x-axis means it's p, right? And let's simplify this. We have to find an equation of q in terms of p. Okay, so log 10q. And that's it. So in place of y, in place of x. These are the things to be noted. Right? And let's simplify. Log 10q plus 1.3 equal 2.7p. Take this 1.3, isolate the q. Log 10q equal 2.7p minus 1.3. I want q. So when log 10 get transposed, it will go 10 power. And all in the right will raise to the power. So this is q in terms of p. This is an exponential equation we call. Hope it might be clear. That simple it is. Now, next part. Okay. B part have a separate description. Let's understand. Jen also investigates a relationship between the same data, Q, and some new data R. Now we are going to relate Q and R. She believes that the data can be modeled with this equation. Q is equal to A times ln R plus B. She thought, okay, this data can be related in this way. And she decided to create a scatter plot to verify her belief. State what expression Jen should plot on each axis. In axis, what should? So this is actually horizontal axis, right? So ln R on x-axis will be best. A, B are constants. And Q is output, like it's the main product function. So Q on y-axis will be the best. Okay. Or you can choose in this way also. It's not mandatory. Ln R on y-axis is also fine. Q on x-axis is also fine. Okay. So best you can write ln R on one axis, Q on the other axis. So they can take in either way, right? That's simple. Now moving to the third part. Okay, now the scatter plot has a linear relationship and Jen finds A and B value for the previous, that is the one we are relating, Q and R. Okay, so she got A is 4.3 and B is 12.1. Now find the equation of P in terms of Q. Okay, let's start with a given clue. So this is my model function, the latest model. A times ln R plus B, and she found the A and B values. So Q is equal to 4.3 ln, it's look like 43. 4.3 ln R plus 12.1. Right? And let's go. We have to find P in terms of Q. So how to get rid of this R, right? I know that P in terms of, actually it's R. That's an error. P in terms of R. Okay, I know P in terms of Q or P and Q connected. Now, let's go. We already did Q in terms of P, correct? The first part. We're gonna use it because I want to interrelate Q and P and R. So take, consider Q is equal to, we know that Q is equal to 10 power 2.7P minus 1.3. This we know. And we can substitute it over there, then P and R will get connected. That's the D, right? So on the left side, use it over here. 10 power 2.7P minus 1.3 equal 4.3 ln R plus 12.1. This is actually an expression connecting P and R, but not exactly P in terms of R. So we need to do some more extra stuffs here. P should be at the base, not at any other different form. Okay, here 10, I should bring down that P to the normal position, right? So it is an exponent. To remove the exponent, I will take log 10 power. So I will take log with base 10 on both the sides. Take log 10 on both the sides. And I will get it like log 10, 10 power 2.7p minus 1.3 equal log 10. Okay, make use of the whole bracket, ln R plus 12.1. And this will give me what happened. So log, this will come in front, right? So 2.7p minus 1.3 into log 10, 10. This is using the rule log x power y. If you have, you can write y into log x. That's the rule I have applied here. And this is equal to log, let it be as it is. Log 10, 4.3 ln R plus 12.1. Then 2.7p equal, what happened to this? Log with same base and same input, like same to same base and input, it will become 1. So that is, and I'm just transposing that 1.3, you will get log 10, 4.3 ln R plus 12.1. And then outside of the log, it's 1.3. And that's it. You want to express P. So P is equal to log 10, 4.3 ln R plus 12.1 plus 1.3. So the parentheses and the usage of brackets should be clear. Right? So this completes the solution. So that's it. Thank you so much for listening. Let's meet in the next interesting video.